Hey, Finlay back again. Today we're going to make a routing template so we can route out the pockets on our string and the riser boards. So we get our template piece, and just to be solid, I'm going to lie it on the string with the edge of the template piece flush with the face edge. And I'm going to measure my margin line down off it as if it were the string at 35 millimeters. I believe that's what we made our margin line. Going to rule that in nice and straight. You can see that should align with the margin line on our string when the time comes. What I'm going to do now, I'm going to take a measurement from the outside edge of the template, 150 mil up, and I'm going to put a mark on the margin line at that point. Hold my ruler on 50, mark 150 in. I'm going to use that as the set out point for where my tread meets the set out on the string underneath of the progressive measurement as a reflective location. This will then match the string underneath. We get the steel square, we align the steel square with our going of tread measurement on the blade and our riser height coming up to match the margin line. We get that fairly accurate. We strike a line there representing the top of the tread, just like we did on the string. Can move that out of the way. We know our tread material is going to be 35 millimeters thick, so I'm just going to mark that line for the thickness of tread. As we remember, we're using 390 by 35s as our tread material with a 5 mil gap in between them. So I've just marked the top and bottom tread line there, as you can see. I'm going to use sliding bevel. I'm just going to set that to the gradient of the riser height, or the riser, pardon me, the riser off the face edge of string. I'm going to slide it down. I'm going to mark the front of the tread, face edge. I'm going to measure along the 290 millimeters that we designate is the depth of the tread material, 90, 1, 90, 1, 2. There it is at the back. Again, I'm going to use my sliding bevel just to firm that line in. Extend those slightly short upper and lower tread lines to that mark. And we've successfully marked out the tread pocket on our template, which would directly reflect the string underneath, the string material. Perfect. Now we want to mark in the riser board. Remember, on the bottom 3 treads, we're closing off the clear space between treads. It's no longer an open riser. We're going to drop a riser board in there. So we need to route a slot for that as well. For me to find the right place for where the riser board will come in and strike the underside of the tread, I need to know how far back the tread material is underlapping the tread above. So I know the length of my going of tread that I used in the calculation, and I know I have 390 by 35s with a 10 mil gap. in between them. So in this case, it allows me to have a 30mm nosing margin. That's how much the tread material underlaps the tread above to create a 30mm nosing margin. So at that point I can put a mark 30mm underneath, which is what I just set up then, across that bottom line from the face edge of the tread. Pop my sliding bevel on. Start a line there to show the front face of the riser board. That will represent face side riser. We'll be using a riser board that is 26mm thick. So I'm just measuring back from the face mark, 26mm, and I'm extending both those lines down. Just checking I've maintained consistency. I actually haven't. That's actually got a little bit wider as it's gone down. You just got to check you don't make those sort of errors. There it is. So I've now represented the tread and the riser board for my template. What I want to do now is show the wedge line underneath that I'm going to also cut out of my template. Just show the depth of that riser board first. I want to show the wedge line underneath there, because we're going to be sliding a wedge in underneath both the back end of the back face of the riser and the back side of the underside of the tread, and that wedge is going to hold those two components in the string. And the ratio for those two is 1:12. For every 1mm vertically up from a right angle, I go 12mm along and connect the two, and I end up with the gradient slope. So I can put a naught behind each of those, and it's the same as 10mm up from a right angle vertically up, and then 120 along and connect them, and I've got my angle. So that's what I'm going to do from the inside corner where the back edge or the back side of the riser connects with the underside of the tread. From that point there, I'm going to go 120 along, mark 10mm up and connect the two lines. Putting my ruler on 20, going 120 along at right angles, coming up 10mm, and I connect the point that I started with that intersecting 10mm line. Then I get the wedge angle that I'm also going to cut out of my template. So when I come to route the string, that will be transferred into the string material. I'm going to do the same thing behind the riser board. 120mm down, 10mm out, connect the two. We do the same thing to mark it in, and we end up with the wedge line that sits nicely underneath or in behind the riser. And as you can see, I'm just going to extend that line from a cut in my template on the back of the tread, 10mm along. Firm those in so they're really clear for you to see. And we're ready to cut it out. And that's what you can see we have there. We've actually now got the going of tread on the tread material in relation to the margin line on the string with a 30mm nosing in this case, and then the riser board dropping, or the cutout for the riser board dropping directly under it, with our wedge allowance underneath as well. So you could see once that was routed into the string, I could pop the tread material in, put the 10mm gaps in, insert the wedge underneath it, lots of glue, and the thing will lock together. That's great. Wedge, the template material in this case is about 4 to 4.5mm thick. So it can actually be cut out with a jigsaw. It can be cut out with a 185 circular saw plunge cut. It can be cut out with a panel saw if you like. What you have to make sure of, I'm going to do a couple of wafer cuts in that hole and break the material away. And I'm going to plunge cut the top line, leaving the line on and making it beautifully straight. As you can appreciate, any deviations when I cut out that hole, cut out the waste material, so I end up with the outline of the riser board and the tread, any deviation in that, and it's going to be seen as the customer goes up and down the stairs. So I need to make sure that top line and front face edge nosing line of the tread material and the front face side of the riser board is nice and straight. And I'll show you how to do that when we come back.